Okay, I'm Jadi and welcome back to the second part of Hacking the Pac-Man, our nostalgic game. On the first part, what we did was we downloaded and ran the Stella emulator for the Atari. It gave us a window which is practically an Atari console. Then we downloaded the Pac-Man ROM and played the Pac-Man. We found out we are dying too soon. So we entered the debug mode using this lovely key on the Stella, which is near the one. It's called tilde or whatever it is called. And then what we did? Found out where in the memory our lives are saved, changed that manually, so increased our life. Then we created a new ROM with this improvement code. We found out where in the code our lives are decreased, try to increase it, and then replace the whole thing with a NOP operation, which let us play without the decrease of our life. But still we have a problem. Each time I go into these sprites, I die and I have to start over. I don't want it. Although it doesn't decrease my lives, I still have 3 lives, but I want to do something more fun. First, let's do a small review. My score at the moment is 15. I will enter the debug mode, search the memory for the 15. It says this is the only place with a 15 in it. So it's very easy. I can increase this to 88. Although I think this is in the hex. I think I did something wrong. Let's see. I will run the game to see. Yes, it's not in hex. How come? Anyway. I have that magical thing. What I want to do in this part, I want to find the collision detection, because now when I collide into these sprites, I die. I want to... Is it a sprite or a sprite? I don't know. Anyway, when I encounter to these ghosts, I die. But we have to know the correct pronunciation because it's going to be important. I will enter this. Atari sprites resource. Sprite. Okay. Sprite. So what I'm going to do is first we need to talk about Atari sprites. No. Atari 2000s. On the hardware level, Atari, we saw the CPU. But it used to connect to the TV. So its graphics is different than what we have now. It understands a few sprites. For example, it understands 2 8-pixel bitmap sprites, 2 1-pixel missile sprites, 1-pixel ball sprites, a 40-pixel play field. See? It's not working as a modern game. It has specific number and style of sprites. It has 2 bitmaps sprite 8-pixel. This is called P1 and P0. Player 0, player 1. You can say draw player 1 here. This is the algorithm for player 2. Player 0 and 1. It has 2 1-pixel missile. English with Jadi. As you can guess, English is not my main language. What we can learn? Missile. Sorry for bad English. Anyway. So, you have 2-pixel, 1-pixel missile. So that is M0. 1 pixel ball, a playfield. These are specific sprites you can make and use. For example, if I want to create a very classic Pong game, this will be player 0, this will be player 1, and this might be the missile or the ball, whatever. You can say, okay, in each loop draw this and check if missile 0 has hit player 0. If yes, do something. This is something which Atari provides as specific bits, and you can read them and you can check them. So this is how it works. If it's confusing, let's go back to the Stella. In TIA, you have all this information. See, you have the player 1, you have player 0, player 1, missile 0, missile 1, and BL. If you go to the debug console, debug colors, the colors are debugged. I will run it and see what happened to the colors. If I go back, you have here, see? Player 0, this is the color. So, this is player 0. Player 1, is this the color? So, I am player 1. What I know at the moment is player 1 is me. Player 0 is the ghosts. But at the moment I see only one ghost. What happened to the others? Let's see. Here you have one button. We've seen it goes step by step in the program. You have one button which is frame plus 1. It will draw the next frame. Each time it is drawing the next frame. Let me go a little bit further. I want to make the ghosts move apart from each other. Okay. But see, at the moment, I only have one ghost here. As you remember, we can only have 2 sprites. One P0, which is P1 in this game, one P0. So, each time I draw the next frame, it draws another one of the enemies. So practically, each loop works only of one of the enemies because we only have 2 sprites for them. See? And each time they move. This is so fun. That's why they are kind of shady and blinking when we are playing the game. See? This is not a programming nice trick. This is a malfunction in the program. Not a malfunction, it's a feature. And if I eat this, same thing will happen. Each time it's drawing only one of them. Okay? Now what? Now we have to find out what happens when our sprite hits one of these sprites. Let's go very, very close to it. Now it's very good. See, in this frame, this is the only one which is shown. I will go to the next frame. Now this is the one which is drawn. Now I will go to the next frame. Now this is the one. The next one will be mine. Frame runs the program up to the finish point of the next frame. But we also have this trace, which is a concept in the TV. When TV shows something, at least in old TVs, it starts drawing from here and goes forward and draws everything line by line. Okay? This is what the trace does. Trace does one. No, sorry. This is what scan does. Scan draws line by line. And see, it's drawing line by line, drawing the next enemy. P0 hit the PF. What is PF? You can search here. PF is this color because I'm in the debug colors mode. So it changes the color based on the sprites. So this hit the wall or hit one of these points which I can eat. I will continue the scan. So we have not hit each other. I go to the next frame. The drawing of this frame is finished. I will go to the next frame. The drawing of the next frame is finished. This is drawn. Next frame, this is drawn. Now I think it should show me. So I go to scan 1 again. No, so I go to the frame 1. This is shown. I go to the scan 1 again. I want to see when I hit, what happens here in this collision detection system. Scan 1. It's closer to me, but not hit me, have not hit me. So I will go to the frame 1. The next enemy, next enemy, next enemy, next enemy. Still not hitting me. Frame, frame, frame. Now I will go with scan 1. You see, each time I go forward, it shows where in the memory has changed, what parameters in the CPU has changed, and everything. I will continue. Still not hitting me. I go to the frame 1. Frame 1, frame 1, frame 1, frame 1. Not hitting me. It's getting further than me. So, I will continue the game normally. And we'll go for another suicide mission. I died. So I will run it. I want to find exactly the closest moment to my death. Okay, one more time. Frame plus 1, this enemy, this enemy, this enemy. I will go with scan 1 because we are very close to each other. I'm not sure which enemy is going to be drawn this time. Very close. Continue to scan. Whenever we hit each other, one of these should turn on this Atari hardware level. So I'm going to find out which one, not this one. Frame plus 1, scan another one. Part of the cracking, hacking, and everything like this is the patient. See? Now we hit each other. So P0 hit P1. This is what we should check in the code. It's very difficult to check because this is not a write. This is a register in the hardware. And we cannot make a trap to see when this is checked because on each loop this is checked. What we can do is go to the documents and see how the program understands this. I will go to the documents and say Atari collision detection. But this is not our Atari. I want the official document, not the chats. Atari Wiki collision detection 2600. What is this? No. Programming the Atari CPU. TIA is what we are looking for. Television interface adapter. It can understand the collisions. I want a table to show which registers I have to check. No. I just want a simple table to show this. One more Atari 2600 P0 P1 collision. Releases. This is what we are looking for. See, here, what? From the previous page. Here I need the collision between P0 and P1. So CXPPMM is what we need to check for the collision. CX, remember? CXPPMM is the register. Whenever it's in this state, it will show that we have a collision between P1 and P0. This should be checked somewhere in the program, and we need to find it. I don't know how I should search here. I did a search on the internet, but didn't find how I can search in the code in Stella. But no issues. It's a very, very small code, and it's very easy to just see using your eyes. Very classic method of seeing. See, for example, here it's checking CXM1 with P. If I have a collision with any of the players and one of the missiles. Here. See? LDA. Let's write the address F5D9. F5D9, just to remember where were we. See? F5D9. Remember the F5D9. F5D9. Okay. Here, it loads the accumulator from here. So it's checking if we have a collision between P0 and P1. And then it does a BPL to this address. What is BPL? If you don't know, you can easily search. That's why I'm saying this is a very good entrance to the assembly language. It would be much, much, much better if they taught assembly using this method, in my opinion. At least in the beginning, they would show a game and then go deep into it and you understand the CPU assembly language. And then they can have a course on all the needed, at least, most important opcodes. Okay, BPL, what does it mean? In BPL in 6502. BPL. Branch if positive. So it jumps if the previous calculation was positive. If the flag is clear, then added the something. For sure, we have branch not if not equal, branch if minus. It was branch if positive, so we will go with branch with minus. We have to see the opcode. Opcode for branch minus is 30. I'm not sure what I'm doing. This is most of the times what happens in the cracking and reverse engineering. You are not exactly sure what is happening here, but you saw that, okay, it's checking the CXPPMM, which is checking if player 1 has hit player 0. Then it has a branch. I will try to negate this branch. Now this is branch if positive. I will go with branch if negative. Opcode for branch if minus is 30. So I will change that 10 with 30. Let's run the program. We were on F5D. B. Okay. Run. To make it more nice, we can also stop this debug colors. So we have the real colors. As soon as it started, I died. So my branch was wrong. It was checking if this has happened, then go to the die. Now I'm saying always go to the die. What can I do? I can stop this. We were on F5. F5. This was it. So we can go here and branch if minus, we can change it to branch if not equal. What is this? The opcode is D0. D0. Now it's branch not equal. I'm just changing the condition of the jumps. And I will run it. Hooray! We did it. See, now it's checking that one. It used to... I don't need to run anymore. It used to branch if positive or something. I replaced it with branch if negative. It was jumping all the time, which is still not good. Now I'm saying branch if not equal, and it doesn't branch any time. So now I can bypass that collision detection in Atari. Again, you can do the same thing on the game you like and ruin the whole game, because now it's not fun at all. Yeah, no, it's not fun at all anymore. Anyway, but at least doing it was fun, but we ruined the game. I think I have to start series and call them ruining the fun games. We can just play and play and play, and we will never die. Okay, hope you enjoyed it. You cannot enjoy the game anymore, but at least I hope you enjoyed the process. And again, the good thing you can do yourself is download the Stella, have a look here, have a look at the code of the games you like, and start hacking them. This will give you a better knowledge. It's like doing karate or yoga. Practically, you are practicing your skills, you are sharpening your saw, and you are getting a better understanding of how the systems work. Seeing the back scene is always nice. Thanks for watching this. I will be very glad if you subscribe, and I may create more videos. I'm enjoying this. Thank you, guys.